recognition using deep multi-pose representations. This work has been done by myself and a number of colleagues and students at both ISI and USC School, Viterbi School of Engineering. The work has been funded by IARPA JANIS program. We would like to thank IARPA for funding our project. There are a number of objectives for the project that we have. The ability to handle pose, illumination, expression, recognition problem, which is well known as the. How can we achieve state-of-the-art performance without FaceNet? They use, I think it's 200 million. The academia and basically the public. The largest publicly available data set up to above 500,000 images. 2 weeks ago, Oxford released the 2.5 million images, which is still much smaller than Google's FaceNet. And then, how can we develop a face recognition system that does not new subjects? Given these objectives, we decided that we will not use any classifiers. Where deep convolutional neural networks as classifiers. That's it, and we will network with huge amounts of data to figure out we will not train on any in-domain data. All of those computer graphics to poses that we haven't seen before. So basically, these are basically the outlines of our technical approach. If you look at, basically, this is a single pose feature extraction pipeline. This is more or less the common pipeline that everybody uses. We start by landmark detection, role correction, face alignment, and then we use CNN for feature extraction. We use PCA for dimensionality reduction, and that's it. And then we use the output of that CNN as features. We don't use the CNN, as I mentioned before, for classification. In order to be able to handle basically poses that we haven't seen before, we extract a very large number of facial key points from each face that we were giving, and we use computer graphics to synthesize or render views that we haven't seen before for that person. And as you can see here, given one image, as I said, we extract facial landmarks, 64 facial landmarks using LP Morency's open face code. And based on that, we extract more landmarks inside the face. We use rendering to come up with scenes with poses that we haven't seen before. And then using this, given the top left shows basically two input images for an unknown subject, what we do is we use these two input images as real images, real input images to our system, and we render what we don't see. Each image is fed into its own CNN pipeline to extract features, and then we perform score fusion. We decided to focus on alignment and feature extraction because we think this is the most important steps for face recognition. And we tested on IGBA dataset, NIST's IGBA dataset. Why not LFW? Because it's saturated and we don't believe it's really in the wild. Each subject is represented by a single image rather than a template. IGBA is each subject is represented by a number of images across different poses, ages, expressions, and so on. And it also evaluates both verification and identification. This is a sample template for one of the subjects in IGBA. And the summary of our performance results is that 90% true acceptance rate at 1% FAR, 95% rank 10 accuracy. Thank you. Please come see our poster.